In this video, we will learn how to compute epsilon closure of any epsilon NFA. Before that, we will understand why epsilon closure is required. We have so far understand what is DFA, what is NFA, what is epsilon NFA. In fact, power of all these three automata is same. That means language generated or recognized by DFA, NFA and epsilon NFA is same. The construction wise, DFA is slower. Construction of DFA is slow compared to NFA, and construction of NFA could be slower compared to epsilon NFA. But the recognition of string in DFA is faster due to its deterministic nature. There is no backtracking. Whereas in case of NFA and epsilon NFA, there could be lots of backtracking for recognition of string. So they are slower compared to DFA. The DFA requires more memory because when we convert NFA to DFA, it could have 2 power n states. So if our NFA contains 4 states, DFA could have maximum 2 power 4, that is 16 states. It is slower, but it requires more memory. And to avoid that, what we can do is, first we'll see how we can construct epsilon NFA. In fact, we have already discussed in previous video. We will learn how to convert this epsilon NFA into NFA. We already know how to convert NFA into DFA. Okay, you can refer the previous videos. And we also know how to minimize the DFA from DFA, right? How to find the minimized version of the DFA. That method also we have already discussed. You can find appropriate links in the description box. So our flow would be like this. We will construct epsilon NFA, convert into NFA, convert that NFA into DFA, and then minimize it. So we will get the DFA with the minimum number of states. Memory requirement will be less and the recognition of string would be faster. We can also construct DFA directly from epsilon NFA. There is no need to convert it into NFA. That also we are going to discuss in upcoming videos. To convert NFA into epsilon NFA into NFA, we need to find out epsilon closure of all the states. So let us first understand what epsilon closure is. So epsilon closure of any state Q is a set of all the states that can be reached following 0 or more epsilon transitions from state Q. So given any state Q, to find the epsilon closure, we have to find out the set of all the states where we can move from state Q just by reading epsilon. That forms the epsilon closure of state Q. Let us try to understand it with the example. The epsilon closure of Q is Q because you can always reach to current state without consuming any symbol. So make sure that every state is epsilon closure of itself. That is the default rule. If we have like this, we can move from state Q to state P by consuming epsilon, then epsilon closure of Q would be Q itself as well as state P because we can reach to P by just consuming epsilon from state Q. If we have automata like this, then epsilon closure of Q would be Q itself, state P and state R because by reading epsilon from Q, we can go to the P and R. So epsilon closure of Q would be Q, P and R. So that should be clear now that what epsilon closure is. Let us find epsilon closure of all the states in given epsilon NFA. So we will start with the initial state Q0. And as you can see that from Q0, if we read 1 epsilon, we are moving to state Q1. From Q1, if we read epsilon, we are moving to state Q4. From Q4, if we read epsilon, we are moving to state Q5. So all these states will be in epsilon closure of Q0. So Q0, epsilon closure of Q0 is a state Q0 itself as well as all the states which are reachable from Q0 on epsilon moves. So they are Q1, Q4 and Q5. Epsilon closure of Q1 would be state Q1 itself plus remaining states which are reachable from Q1 on reading epsilon. So from Q1, if we read epsilon, we are going to Q4. From Q4, by reading epsilon, we are moving to state Q5. So epsilon closure of Q1 would be Q1, Q4, Q5. In similar way, the epsilon closure of Q2 would be state Q2 plus Q6. Epsilon closure of Q3 would be Q3. By reading epsilon, we are moving to Q4. and by reading epsilon we can go to the Q5. So these three states will be in epsilon closure of Q3. Epsilon closure of Q4 would be Q4 as well as Q5, and that of Q5 would be Q5 only, and Q6 will be Q6 only. So again I repeat, every state is by default epsilon closure of itself, and we only have to add remaining states which are reachable from the state by reading epsilon. Let us consider another example, and we have to find out epsilon closure of all these states. So from Q0 we can move to Q1, from Q1 we can move to Q2 and Q4, and from Q0 we can also move to Q7 just by consuming epsilon. So all those states will form epsilon closure of Q0. From Q1 we can go to state Q2 and Q4 by reading epsilon. So the epsilon closure of Q1 would be Q1, Q2 and Q4. From Q2 there is no epsilon transition, so epsilon closure of Q2 would be Q2 itself. For Q3, Q3 by default, then by reading epsilon we can go to the Q6. From Q6, if we read epsilon we can go to Q7 as well as Q1. From Q1 we can go to Q2 and Q4 by consuming epsilon. So all those states would be the part of epsilon closure of Q3. From Q4 there is no epsilon transition, so only Q4 would be in epsilon transition of Q4. From Q5 we can go to Q6. From Q6 we can go to Q7 and Q1. From Q1 we can go to Q2 and Q4. So all those brown or red states will be part of epsilon closure of Q5. From Q6 we can go to Q7 and Q1. From Q1 we can go to Q2 and Q4. So Q1, Q2, Q4, Q6, Q7 would be part of epsilon closure of Q6. And from Q7 there is no transition, so only Q7 will be the part of epsilon closure of Q7. Let us consider one more example. Here from Q0 we can go to Q1. From Q0 we can move to Q1 and Q2. From Q1 we can go to Q4, and from Q4 we can go to Q3. So all those states will be in epsilon closure of Q0. From Q1 we can only move to Q4. So epsilon closure of Q1 would be Q1 and Q4. From Q2 there is only one transition on epsilon move, that is Q4. So epsilon closure of Q2 would be Q2, Q4. For Q3 there is no epsilon transition anywhere, so only Q3 will be in epsilon transition of closure of Q3. For Q4 we have a transition to Q3, so Q3, Q4 will be in the epsilon closure of Q4. So this is how we can compute epsilon closure of any given epsilon NFA, and in upcoming videos we will see how to convert this epsilon NFA into NFA using epsilon closure. So we are going to discuss the applications of epsilon closure in next video. Thank you. That's it for today folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.